Hi class, so we're on to week 3 of the experiments. We all completed experiment 2 last week. For week 3 we're doing identifying an unknown compound, so we're really just learning how to make more proper observations in lab. Please note you have a post-lab assignment due in week 3, so do not forget that, please. It's still part of your experiment 2 grade. Now let's move on to experiment 3 for this week. So the experiment 3 is titled Identifying an Unknown Compound. The goal of this experiment is really to perform a series of tests on 9 standard compounds and also your unknown. Another goal of this week's experiment, so you're going to be performing these standard tests on your 9 compounds and your unknown, but another goal is to identify this compound, identify your unknown compound, and please make sure you write down your unknown number in your notebook and write down your identification. But more so, it's really important for you to discuss your results with your lab instructor or TAs. Another goal and final goal, which you're graded on for this experiment, is to generate a qualitative. Remember in the first lab we talked about quantitative and qualitative observations. This week's lab is all on qualitative observations, so you're going to generate a qualitative analysis flowchart to help you identify your unknown. As always, before you start listening to the pre-lab lecture, make sure you have read through the entire experiment so that this pre-lab lecture actually makes sense. So at this point, if you didn't read the lab, stop, read the intro, read the experiment, and then resume. Okay, I'm assuming you've all read the experiment in your lab manual, so let's go over some concepts. So this experiment has several parts to it, as will most experiments. The first part is really just making observations of physical appearances of your compounds. So again, we have 9 compounds and your unknown. So just to kind of reiterate and really emphasize how to make proper observations. So if you take a look at these 2 powders here, well, first of all, what you can describe, or what's pretty evident in these 2 powders, is that they're white powders. Now, if you just say white powder, that doesn't help your reader really know what you're talking about. So we always kept saying your lab notebooks should always stand on their own, meaning your observations should be so descriptive that a random person can pick up your lab notebook and make sense of what you're actually talking about by observing different things in the lab and from your lab notebook. So one big don't is don't call this just white powder. That's really not helpful, and you're going to see that actually most of the compounds you're working with are white powders. So that's one big don't. Do's, so what's the proper way to actually describe these 2 substances that are just white powders? Well, okay, so you're going to have these compounds in jars. I want you to turn the jars, kind of shake them around, get a feel without actually physically touching the material. So by doing so, well, this powder, well, it's definitely white, so I should write the color. It seems soft and fluffy, almost, powder. Think of baking powder. Baking powder is very soft and fluffy. Now this powder, on the other hand, well, it's also white powder, so let's write down the color. But it's not just white, it's actually grainy. So a good observation of the physical appearance of these 2 compounds, well, this one's white, soft, fluffy powder. This one's a white, grainy powder. So that's what really the objective of part 1 of this experiment is to correctly identify your standard compounds and your unknowns, make observations of your standard compounds and unknowns. The second part has to do with the solubility of the compound. So before we go in, let's actually talk about solubility itself. So solubility is actually the amount of a substance that can be dissolved in a given quantity of solvent. So early on we talked about solute and solvent. In this lab, your solvent is water, H2O. One thing that's really important to know, so it's not just adding an amount of solvent into your solute or amount of powder into your water and watching it, you think it's going to dissolve on its own. No, sometimes you actually have to stir it, sometimes you have to mix it. One thing I observed from last week's experiments, never put your finger on top of a test tube and mix. That is very dangerous. So your lab instructor can demonstrate how to properly mix a test tube. You can also use a stir bar to mix your substances. One thing I want you to know is that anything that is insoluble in water will never dissolve regardless how much you mix it, how much you heat it. So please note, compounds that are insoluble in water will never dissolve regardless of how much water we add. Now, I keep telling you, think of real-life examples when we talk about chemistry. A great example of this is sand. Sand will never dissolve in water, regardless how much water you have. A great example is the ocean or the beach. Sand doesn't dissolve at the beach. We'd have a big problem if it did. So again, think of examples that you know are applicable. We also have issues of reaching saturation, what happens when you exceed saturation, but that's not of importance for this experiment. We'll talk about that when the time comes in the semester. The third part of this experiment, and again, please follow instructions very carefully. One important aspect is in your procedure, it says place a spatula tip. So let's pretend the tip of my pen is a spatula tip. That's literally how much amount, this tiny tip, how much amount that you actually really need for your the amount of compounds. So please just preserve the compounds, use the amount that is actually requested of you. The third part of this experiment deals with acid and base properties. This is the introduction of acids and bases. Most of you are going to go on to other courses where acids and bases are very applicable. So this is actually relevant for future courses that you take, as well as this course, of course. So in case you're not familiar with acids, acids are known as compounds that donate a hydrogen plus ion. We often refer to this as a proton. And again, we'll talk about acids and bases later in the semester. This is just an introduction for you. An acid, or acids, are also compounds that have a pH less than 5. Some textbooks say pH less than 6. Acids also are known to react with metals to produce gas, and oftentimes that gas is hydrogen gas. And acids are known to react with bases to form water and ionic compounds. And oftentimes we refer to these ionic compounds that are a product of acid-base reactions as salts. An example of an acid is HCl, hydrochloric acid. Again, we'll talk about acids later in the semester. We'll even learn about naming acids. Bases, on the other hand, so if acids donate protons, bases accept protons. And they have a pH greater than 8. Some textbooks say pH greater than 7. Never feel a base, but if you happen to feel a base, which actually we use bases every day in our lives, soap is a base. So bases oftentimes feel slippery. So again, I never want you to feel anything in lab. That's not safe, even if you have your gloves on. But just kind of bring a real life example. An example of this, a base is a soap, or soap is a base, and we know that soaps are slippery. And similarly to acids, bases react with acids to also form water and an ionic compound. And again, we oftentimes refer to these ionic compounds as salt. Now, neutral compounds, well, as the name says, they're neither an acid or a base, and they usually have a pH in the range of 6 to 7-ish, okay? So that's part 3. Part 3, you're really dealing with acids and bases. You're also performing litmus paper tests, and you're performing behavior of these compounds in acid and or basic solutions. So let's talk about the litmus paper test. It's really important, and I wrote this in red. Only do the litmus paper test, and this is again in your lab notebook, in your lab manual. Only do the litmus paper test on compounds that are soluble in water, so ones that completely dissolve in water. And I want you to use the test tubes from part 2. Again, follow instructions carefully, and this lab will be completely seamless. So, an example of a setup so first of all, I want you in your lab notebook to make observations of the litmus paper. So for example, the litmus paper initial observations is I want you to write the color of the litmus paper, the initial color. But in your lab notebook, I also want you to write the result of the color that you get when you treat it, when you put it into your soluble compounds in water. So you write the initial color of the litmus paper. You should only do this once, and then I want you to write the result of your litmus paper test from in your lab notebook. So the result of putting litmus paper into your compounds that are soluble in water. Your lab instructor should demonstrate on how to properly do this. Never take a piece of litmus paper, and please use small pieces of litmus paper. It just has to be a little tiny amount. You can even say, again, the tip of the pen. That's how small it has to be. Never put it into your test tube, because then it's going to discolor your test tube, and you're going to think a chemical reaction is happening, which is not exactly. What you should do is take your test tube, put your spatula tip, a clean spatula tip in your test tube, and then dab it on your litmus paper. So just for reference, so this is kind of a reference table here. For acidic compounds, it should turn your litmus paper red, or some shade of red. For basic compounds, will turn your litmus paper some shade of blue. And then neutral compounds, it's just going to look like wet paper. That's why it's really important to make that initial observation of litmus paper, so you're not deceived thinking that it's acidic or basic. The second part of part 3 for this experiment that's under acid and base is you're going to investigate the behavior of your compounds in acidic or basic solutions. So I want you to take a spatula tip, again a very small amount, of your compound, add 10 drops of HCl in that, and then add 10 drops into another test tube, add 10 drops of NaOH. I want you to make observations. Again, make sure you make initial observations of hydrochloric acid, initial observations of sodium hydroxide. Make sure you also write your concentrations in your notebook. One thing to note is that if you have a basic compound, it's going to react with an acidic solution to produce hydrogen gas, and it may also generate heat. If you have acidic compounds, you're going to see the same exact reaction. It's going to produce hydrogen gas and generate heat, then we call that an exothermic reaction. You know which compounds are acidic and basic based on this test. One thing to note, if you have an acidic compound and you add an acid to it, you're not going to see any reaction at all. Okay? So these are signs of chemical reactions, just like we went in chapter 1 and chapter 2. The last part of this experiment is to generate a qualitative analysis flowchart. So a qualitative analysis flowchart is basically a diagram which shows a logical sequence of results. It's basically a really neat way to put together a summary. So let's do a basic example, and then I'll do a little bit more difficult example. So you state your question on top. How do I identify that light in the sky? So the question for lab this week is, how do I identify my unknown? Well, one question you could ask yourself, so you always ask yourself, first of all, let me backtrack. You always ask yourself yes and no questions. And these yes or no questions have to be very specific. If you notice here, everything that's in a red box, you can never have repeats, right? So your flowchart has to be very specific so that you have, well, one question will always answer sun, you'll never have sun anywhere else. Okay, so let's go through this. First question, is it really big? If you say yes, well, then ask yourself a follow-up question. Are your retinas burning? And if the answer is yes, then it's the sun. If your retinas are not burning, it's the moon. If you answered no to this question, you can ask yourself, is it moving? If you say yes, okay, then ask yourself another question. Is it moving so quickly that you almost missed it? If you answer yes, excuse me, ask yourself a follow-up question. Is it extra super bright? If you say no, then it's a meteor shower. If you say yes, well then ask yourself another question. Does it end with a dramatic explosion? If you say no, it's a fireball. If you say yes, it's a bolide. So, etc. So I want you to kind of go through this flowchart and try to understand really the gist of a qualitative flowchart. The questions you ask are very specific, and they're really yes or no answers, okay? For example, is it acidic? Yes or no? If it's not acidic, ask yourself a follow-up question. Here's another example, chemistry-wise, of a qualitative analysis flowchart. So we have our compounds up top. You can ask yourself, is it soluble in water? If it's insoluble, no, it's not soluble in water, then it could be this group of compounds. If it is soluble in water, then it's this group of compounds. And you keep going and you ask yourself a series of other questions. How does it react with iodine? Well, if it gives you a deep blue, it has to be cornstarch. If it's not, then it narrows down your possibilities to only 3 compounds instead of 4 what you had here. How does it react with vinegar? Does it bubble? If it is, it's calcium carbonate. If not, then you're narrowed down to 2 compounds. How does it react with 10% HCl? If it fully dissolves, it's this compound. If it does not, it's this compound. So that's an example of a chemical flowchart, except you should actually ask questions. Here, don't just write vinegar. You should say, how does it produce bubbles when it reacts with vinegar? Yes, no. Okay? I hope this is clear. Ask your lab instructors, please, if you have any questions. All right, as always, some experimental logistics. Pass in post-lab assignment 2. No late assignments will be accepted. This is really important because post-lab assignment 2 is 20 points of your grade for experiment 2. That's very substantial. Post-lab assignments are open book, so it's really a great way to kind of boost your grade. I want you to work in groups 3 or 4 for this week, but it's important that each one of you have their own unknown. Make sure you record your unknown number in your lab notebook, and please make observations, initial observations. Please note, you have no post-lab quiz this week. Instead, your entire notebook is 50 points. Observations are key. Please also note, do not put any remaining liquid or solid back into the dispensing jars or bottle. That's a big no-no in a chemistry lab because you can accidentally contaminate the main source. If you have extra, share it with another group or properly dispose of it. So that's it for the pre-lab lecture for experiment 3. Please take the time to prepare properly for lab. See you next week.